Hi, today we're going to be doing systems of equations, and we're going to review first. You've done these before in Algebra 1. Systems of equations are where you need to solve two or more equations at the same time. Now, in the past, you've done only two at a time, but if you go up to upper level math, you may need to solve three or four at a time. So here's our two equations. We got to find the x, y values, the point that satisfies both of those equations. So graphically, all we have to do is graph each one and then see where they intersect. So, apologize. All right, so if I press y equals and type in my first equation, remember that an x squared graph is going to be my parabola, so when I'm trying to figure out what to plot, I want the table that makes that nice pattern. And oh, wow, it's right there. And I also want it to fit the entire page, so I actually want to go back one as well. All right, so it's going to be -1 up to 7. Whoops. Okay, so plotting that, we will get and there's our first graph. And anytime you have multiple graphs on the same set of axes, you should label. Okay, our next graph. Now this is going to be a line, and for a line you can pick any table you want, but because we're doing multiple ones on the same axes, it's a good idea to just use the same table. And I would advise you to get rid of your other one for a second, or on the 84, you can press enter on the equal sign to turn it off. That way, when you do the second table, you can have just one table to look at and not get distracted by the other stuff. Now, in order to graph it in your calculator, you do have to be in Y form. So in order to graph this, you would have to subtract the 2x over so that you get y equals -2x plus 6. Okay, so I turned off the other one, but you can still see it. Okay, so I can see that it's going to turn out to be a line, and then I can go to my table and put these on. And it's a good idea to put your table on your paper, although you don't get penalized if you don't. It just helps you to make sure that you keep track of what points you're plotting, and the grader can see what points you're trying to plot. If you accidentally misplot, they can see your table. All right, so for this graph, and you should know that a line follows a same rate pattern, and once you see that it's going down 2/1, you could just finish the pattern. You also can plot a line by using the slope-intercept method, where you start at 6 on the y-intercept and then use the slope to count down 2/1. Oh. And there's our line. Wow, I drew a really horrible line. Okay, so I'm going to graph or label that one. And lastly, the answers of x, y that will fit both of those at the same time are the places where they intersect. So that point and this point as well. And also remember, equations, the answers are where they match. If you wrote your tables, you can actually see the matches right in your table. So those are our matches, and if you count the coordinates over, you will get those same coordinates. All right, now that's the visual approach, and in all honesty, it's not always the best approach because you have to be able to graph them. Sometimes the points of intersections don't actually fall at nice integer coordinates. So this is nice when it works, but when it doesn't work, the algebra is the way to go. So we're going to do the same problem now, the algebraic way, and it's something, again, you've already done in the past. So I want to stress that when you're solving an equation, you have to understand what you're trying to do. You're trying to find the same x that works all those places, and you're trying to find the same y that works in that. So the y's are definitely easier to work with on this problem because there's only one each in each of the equations. So I'm going to erase this for a second. So those two green y's are the same y. So what I want to do is I want to substitute the one green y's value into the other one. Now, in order to do this, I am going to color code a second. So we have this equation, and right now we have, excuse me. So because we're going to be doing the harder stuff in a minute with our new stuff for the year, you have to understand that these y's right here and right here are both the same y. So if this y equals this stuff, you can do one of two things. You can right now take that and replace it for that y, or we can get the second equation in place of y equals. I apologize, I wrote x there instead. And so then we can get negative 2x plus 6. And then I can take this y value and substitute it in for that y value. Either way, it's going to work. All you have to understand is that you're replacing a y value for the other y's value. And you're substituting basically an expression in place of that y value. So I know most of you guys probably would prefer the way I just did it. But again, keep in mind that it doesn't matter which way you substitute. If you want to substitute this one in place of that one, or you want to substitute this one in place of that y, whichever way you want. So after we get this y by itself, then we're going to substitute this in place of this and come up with a new equation. So your new equation looks like this. Again, all I'm doing is replacing this y for that y and coming up with a new equation. So now we have a quadratic equation, and when you have a quadratic, we're always going to think equals 0. So we're going to bring over the 2x and then subtract over the 6. These will go away. All right, and then we're going to factor this if possible, but again, the completing the square and quadratic formula method would also work. But this factors to b. Setting both equal to 0. Then what a lot of students don't forget is they stop here and they have to realize that when you're solving a system, you need to find both the x and the y values. Now we go back up to the drawing board. Y has two values. Y either equals this or y equals this. You can technically choose either one you want. I'm going to use this just because it's simpler looking. So all I have to do is replace the x value with the 5 that I just found. And there's my -4. So one answer is 5, -4. And the other answer, I'm going to plug in -1. And for that one, we get 8. So our other answer is -1/8. And those exactly are the two answers that we got when we did the problem graphically. All right, so moving on to this year's stuff, we're going to concentrate on the algebra because, like I said, most of the time it's not going to give you nice answers on the graph, and try graphing a circle on a graph paper and trying to get points of intersection. It's not as easy as it sounds. So a system of equations are two equations whose solution is the values of the variables that satisfy both simultaneously. The x and y pair that satisfy both equations at the same time is really what that's saying. So for each of these, we are going to solve them algebraically. Again, this one is your basic one again. I need to understand that this y and this y are the same y. You could replace for x, but if you do it that way, you are making the problem incredibly much harder than it has to be. So you can substitute for either the x or the y, whichever one is easier in your mind to be able to plug into for. So at this point, again, I'm going to do it the other way right now. I know a lot of students don't see this. Again, let me color code. So again, you can substitute either y that you want. So this y right here is equal to this. I could, in this point, put this in place of that y and then have that equation to work with. Or I can do what I just did in the other problem, which is to solve for y here by subtracting that over and then using this y and replacing this y in for here. It doesn't matter. I'm going to do it this way just to show you that this will work. So again, I just took this y value and put it in place of that, just to show you. But if you don't like it the way we did it already in the use what you know, then you may do it that way. So now I'm going to combine like terms. And let's see, I have an x squared. Then I have a 2x and a -6x, which is -4x. And then I have a +5 equals 5. So I have a quadratic. I'm going to get it into equals 0 form by subtracting the 5 over. And I get x squared minus 4x equals 0. So now I have to factor that, and to factor that, I have to take out a GCF. And a GCF of an x is in both terms. So this is not a dots, which is a common mistake. Set both sides equal to 0. And now, at this moment, I have my two x values. I have x is 0. And I have x is 4. All I have to do now is find the y value. And so now it might be a great idea to actually subtract that 2x, because I would rather work with the linear equation. So now I'm going to go ahead and put my x values I just found right in there to find out what the y values are. So y equals -2 times 0 plus 5. And I get 5. So one answer is 0, 5. And then I'll do the same thing for the other value of x. Get -3. So my other answer is 4, -3. And those are my two answers. Moving on to the next question. So the next two both have an x squared and a y squared in it. So for these, again, you can substitute either one you want. However, you want to do the one that you think is going to be easier. So we have this y and this y are both the same y, and we have this x and this x are the same. So at this point, you have one of two options. You can either subtract the 1 over to get the y by itself, or you could actually, in fact, leave it alone and then substitute the y plus 1 right here in place of x. So I'm going to do that just to show you don't always have to have the x as the one that you're solving for. You can sometimes find the y. So I'm going to put in place of x squared right here. Okay, so I'm going to put this guy in place of the x value. All right, so how do we solve this? Well, order of operations, I have to first do the power 2 on this guy. And remember, you cannot distribute the power. You're going to have to remember to double distribute that out. And then you'll get y squared plus 1y plus 1y plus 1. And then don't forget, we still have the plus y squared equals 25. Okay, now we're going to add like terms. The y squared and the y squared make 2y squared. We have the 1y and the 1y make 2y. Then we still have this plus 1 number equals 25. Okay, we have a quadratic, so we want to think equals 0. So we're going to subtract the 25 over. And then we get 2y squared plus 2y. Take away 24 is 0. All right, now we have to factor this. We can do an AC method of factoring on this one, but if you're smart enough to notice this, all of these have a 2 factor in it. So I can make this trinomial easier by dividing both sides by 2. It still keeps the equation balanced. And now my hard factoring problem I just made easier. All right, so factoring, we get y plus 4 times y minus 3, setting both sides equal to 0. I get negative 4 and 3. But again, I twisted it up this time because I solved for the y variable. So now I have to find the x variable that goes along with each y. And I'm going to go back up here and use this one right here. I know that I have 2 answers. I have y equals negative 4, and I have y is positive 3. So I know, but based on that equation, that the x value is equal to the y number plus 1 more. So negative 4 plus 1 is negative 3. So one of your answers is going to be negative 3 for x, negative 4 for y. The other answer comes from the y equals 3. So I know this is true. Plugging in 3, and you get 4. Again, the x is 4 and the y is 3. And those are your answers. All right, we'll try this one more time. All right, so on problem number 3, I again have a system of equations. And there's my x's, and there are my y's. Okay, and on this particular problem, I definitely can figure out that it would be to my advantage to get the x by itself here, because otherwise I'm going to have to divide by 2 to get the y by itself, and you're going to have fractions. If you want to work with fractions, it will work. It's just much harder than it has to be. And like I said, in example 2, we had a choice. We could have plugged in for the y value and solved for x. So for problem 3, really you have no choice. This would be your best option. So now we're going to take this and plug it in for the other one's x value. So that guy squared minus 2y squared is 23. So we're going to put that right in there. Okay, so again, first off, we're going to do the power 2. And that means double distribute, which should be 4y squared plus 14y plus 14y plus 49. I still have the other part of the equation still left. Okay, combining like terms, I got 4y squared minus 2y squared is 2y squared. 14y and 14y is 28y. And then we have 49 equals 23. Subtracting over the 23, and again, I noticed that all the terms have a 2 GCF in them. So I'm going to make my life easier by bringing that over. Factoring now a much easier trinomial. And those are my y values, and all I have to do is find my x values, going back up to the top and using this equation. Y is negative 13, so that means that the x value is equal to 2 times that y value plus 7, which is going to give you negative 19. So one of your answers is going to be negative 13 comma negative 19. The other answer I need to find out for when y equals negative 1. So x equals 2 times negative 1 plus 7. So that's going to be 5. And then my other answer then will be, oh, I apologize. My last answer, I switched the coordinates because I found x second. So I really should have had negative 19, then negative 13. That's my x and then my y. And then for the other problem, my x is 5 and my y is negative 1. There's just a lot of steps. Color code if it helps you see where you're substituting into. Just be careful. There are a lot of steps, and if you make a mistake in one of the steps, it obviously will trickle down and you'll run into a problem.